Eliot Jacobson is a climate researcher and retired professor of mathematics and computer science. He joins us this hour from Santa Barbara in California. Professor, thank you for being with us here on CNN Newsroom.
Glad to be here.
So I want to start with some of your findings and some of the graphs which you've sent us and which are out there on Twitter. I want you to explain them and go through them for us, and then we'll get to what they all mean in a moment. But first, here's a graph of global temperatures measured at 2 meters above ground, so not surface temperature. So the 21 days between July 3rd and July 23rd, every day hotter than the record set last year in 2022. So what was a ceiling in terms of record highs from last year? What, is that now a new floor? Is that where this is all heading?
Well, what's happening is that we're very quickly getting to the 1.5 Paris limit, and in the process, temperatures are just have to rise. This is a natural and inevitable consequence of the greenhouse gases we pumped into the atmosphere. So, yeah, we set a new record this year, and that record is playing out all over the globe in terms of heat waves and other climate effects. We're at 17 and a quarter Celsius as a global average. That previous record was about 16.9 Celsius, so it's a huge year-over-year leap.
Okay, so then there's also the North Atlantic sea surface temperatures anomaly. This is another graph. This is the difference between the current temperatures and 2023 is in the red line compared to 1981 to 2020 with the mean, of 1981 to 2020 being used for 1982 to 2023. So what are we actually looking at here in this particular graph?
So what we essentially do here is we take each year and draw it horizontally as a line. And the location of that line is either above or below the zero line, which indicates simply whether it's an above average or below average year. And so you can kind of see everything is sort of clustered in the middle there, except for this year. And you see that red line just completely spiking upwards. And what that means is that we have a situation with North Atlantic sea surface temperatures that is just unheard of, unexpected, and beyond anything that we really are able to fully understand the implications for.
Okay, and then there's also the daily standard deviations for Antarctic sea ice for every day from 1989 to 2023. And again, the red line we see there is for 2023. We're halfway through the year. So what are we looking at here in terms of sea ice?
So right now it is winter in Antarctica, and so sea ice should be growing, and it should be growing kind of fast. And what that tells us is that the ice is just not growing at the speed that it's grown every previous year. And that deficit just isn't a little bit. Right now, it is close to 2.5 million square kilometers. I think that comes out to about 8 Britons. Worth of deficit of sea ice. And so that's just right now of all the things that are under expectation, that one is by far the one that is sort of off the charts below expectation.
So bring these three graphs together. What are they telling us? What's the future telling us with these three graphs?
Well, I'm going to put it in real simple terms for you. We are witnessing the 6th great extinction right now. We are witnessing the collapse of global industrial civilization. And these are just sort of illustrating a huge step towards those eventualities. They're going to happen. There's no question about it. And so it's the fact that we have all three of these at once. It's just stunning. It's stunning. Climate scientists and everybody else who's looked at these things as a career professional their whole lives, they can't believe this is happening. I'm surprised by just how fast this is all happening. But that's where it's heading. It's heading towards a mass extinction event.
A mass extinction being us?
Well, not necessarily. So the definition of a mass extinction event is 75% of the species on the planet. And so that's certainly what we see happening right now. We have at least 10 times the background rate of extinctions happening globally right now. And typically that the timeline for a mass extinction event is about 2.8 million years. So the actual definition of mass extinction is losing 75% of species over 2.8 million years. We're going to do it in 100 years. That's how fast this is happening.